Hello everyone, I'm François, Product Line Manager from Amphenol Basics, and I will be your host for this webinar during which we will present you our dedicated solutions for PLC applications. As PM, I see my team has a technical and commercial support to help you grow your business and make your project more successful whenever possible. So please feel free to reach out to Basics product managers along with your sales contact people if you need extra help. In today's agenda, we will first have an overview of the Amphenol corporate structure so that you can better understand the position of FCI Basics within our organization and its added values. Then we'll go straight into the topic of PLC, starting with the definition of what a PLC is, the overall architectures and features that we can see on the industry, the trends, and last, the impact of these trends on the typical connectors requirements. In the third part, we will see together how Amphenol Basics existing and upcoming products fit into each usage of PLCs in terms of design, features, and benefits. The next section will highlight some short success stories that illustrate what kind of support Amphenol Basics can bring to you with regards to the success of your future PLC projects. The last part of this webinar will go through an overview of the related product lines for more details. Amphenol Corporation as a whole is one of the leaders of the interconnect industry, with over 15 billion revenues in 2024, coming close to a worldwide leadership. The 110K employees are spread across more than 70 countries, with a large span of manufacturing sites across the globe. The organization is led by Mr. Adam Norwitt, and it is split into 3 divisions, each of them containing several groups. The groups where we belong as Amphenol FCI Basics is commercial product groups led by Gary Ann. Basics BU is a specialist of signal board-to-board and wire-to-board PCB connections, ranging from small miniature pitch to standard ones across 5 technological portfolios: I/O FFC FPC, backplane, board-to-board, wire-to-board, and e-mobility. Among these 5 segments, I'm in charge of the core wire-to-board portfolio, which is primarily designed for industrial, consumer, and IT datacom applications, whether in wire-to-board but also in board-to-board configuration. As you can see, our range of applications is quite large, but always with a focus on added value and customer-centric offer. From our organizational point of view, our strengths lie in our global footprint, including Europe, and engineering resource across 3 different countries in order to guarantee a strong collaboration with our customers and partners wherever they are. Our objective is to expand beyond component provider and serve you as a solution provider. We want to offer you application-specific solutions that directly support the evolving needs of customers in target markets. The manufacturing footprint of our business unit is spread across Africa, Asia, and also Europe. Thanks to these localizations, we are able to serve customers with close local support thanks to our technical and manufacturing resources, and we believe this is the way to ensure that customers' projects are served in the most appropriate and diligent manner. This footprint is also flexible with not only the manufacturing of finished goods, but also added value services such as cable assemblies and engineering support whenever necessary. We will now start with an introduction into today's topic, Programmable Logic Controller, or PLC. To summarize, a quick definition would be as follows. A PLC can be described as a ruggedized computer designed to operate in often harsh industrial settings and environment to manage and automate the process in factories or production lines. As you can see in the diagram, PLCs are part of a large automated ecosystem where they stand among control units. All these machines are designed to cooperate with each other to measure, control, supervise, and coordinate the production flow. Applications are quite large, ranging from medical to utilities, like water treatment station, power station. But manufacturing lines are often known as the most common use case. However, whatever the application, there are several common components which can be found in most of the PLCs. CPU, which are the brain of the PLC, the interface module, the communication module, the power supply module, the PLC rack, and the I/O module. All the listed modules reflect some generic building principles that we are going to see in a moment. First principle, PLCs are usually chassis-based, which means they are connected to different modules over backplane connectors. For example, a DIN rail. This allows a common interface and standardized formats. Second principle, thanks to the chassis-based principle, additional modules can be added or removed to offer flexibility. This modularity can be achieved with board-to-board and wire-to-board interconnect solutions. Third principle, PLC tend towards more and more integrated solutions with a growing number of features within a reduced space. For instance, it is common to see detailed human-machine interfaces on the centralized module, along with several features close to what an industrial PC could offer. On top of these three trends, there is a common, let's say, fashion that more and more integrated solutions will come with open software platforms and innovative concepts, and therefore modularity becomes key. Among the key trends on the PLC market, we can list the following. Compact size and faster processing time. That means that PLCs need to be smaller and process an even greater number of tasks within a reduced time frame. We have also high expectations in terms of cybersecurity. These standards are prevalent and need to be integrated within the PLC features to protect the installations against any external threats. Open source and cloud-based programming platforms mean that PLCs should now be able to communicate and evolve over time, thanks to external resources if required. And on the other hand, we have greater data management and AI features. So like for any machine, AI can offer deep learning and self-improvement processes, but this requires more power capabilities. Another trend is the increased number of functionalities. New sensors, actuators, and IoT devices increase the range of control and the type of information that can be processed by a single PLC. And last, expectation and trends, we can see more and more decentralized control architectures. That means that PLCs should not only rely over a centralized supervision unit, and they should be able to take corrective actions on their own to address issues and improve the system performances. On this slide, we can see an overall breakdown of the PLC system with a schematic on the left showing the main unit used in combination with additional modules. As mentioned earlier, if we list the components, we usually have CPU, which can be described as the brain of the PLC, the input-output module, which can be seen as a translator, the communication bridge, the power supply module, some kind of a plug, and the PLC rack, which is, so to say, the backbone. Now, if we look at the external overview, we can see that each module comes with specific requirements in terms of connectivity, along with common components. Here are some of the typical connectors you can come across in a PLC. You have display connectivity, like FFC, FPC items. We have display interface with HDMI connectors, communication connection, with USB-C, RJ45 connectors, programming ports, expecting SD or micro SD connection, internal connections with headers, port-to-board, wire-to-board connectors, and rack connectors. All of these are part of the, let's say, visible from the external overview. But if we go to the internal overview, you can find signal wire-to-board, ribbon cable-to-board, pin-on socket, backplane connectors, FFC-to-board, I/O. Considering the application, all these internal components are expected to show modularity to meet always higher speeds and signal density. Nevertheless, these proven solutions must be competitive and reliable in the long run. And because of the growing processing power, more and more modules can be added to the system, meaning that modularity becomes a critical factor. In terms of market overview, we can see that PLC market has a fast growing, since it favors standard, proven connector technology with state-of-the-art interconnect solutions. The growth can be explained with the number of related modules added over time and the increasing number of features centralized into CPU modules. Market players are diverse, and we can see small and mid-sized OEMs leading with new automation development. The connectors that we'll show you are standard items available on stock at our distribution partners. So this makes designing even more simple. If we come back to the PLC overview, CPU module is where the product offering from Amphenol Basics is the largest. As discussed, this is where the brain of the PLC lies, as it is responsible for executing the program and communicating with external devices. Therefore, there is a great potential for interconnectivity on both external and internal aspects. For display connectivity, you can consider our FFC FVC series with a low profile design and high pin counts. For board-to-board configuration, we recommend burst stack 0.8 or 0.5, which can achieve high data transfer performances. Then we have our SD connectors that can be located at the programming ports and which are vibration and shockproof to ensure long-term durability. We should not forget about our internal connection, where our Minitech wire-to-board 2 mm shines since it offers up to 38% of space saving compared to standard pitch 2.54. This flexible range can be included in architecture where space constraints are important. In parallel, you can consider Bergstick and Dubox series for their modularity and versatility when standard pitch can be accepted. On this slide, you can see a summary of the main features and benefits of the series that we have introduced to you for CPU module, along with a list of preferred series that can be easily found across distribution and are our standard paths used in these applications. Next, we'll show the connectors to use between modules themselves, especially at the interface modules, which serves as a bridge from controllers to on-field devices. Several designs can be used between I/O and CPU modules, depending on the architecture. Minitech microspeed board-to-board is one of our flagship components, capable of withstanding vibrations thanks to dual beam contact design. The EMI shielding offers reduced coupling inductance, and with 25 gigabits per second, this series is compatible with high-end computing transfers, whereas it will guarantee optimal performances. Secondly, our battery connectors and universal contacts are also robust alternatives to reach a number of mating cycles with high current mating. If needed, you can also consider our USB cable assemblies for quick and easy connections. The next slide illustrates the module interconnection via microspeed solutions. This configuration revolves around sliding the base unit onto the DIN rail to connect the modules on the top end. By doing so, the modules are safely interconnected with a robust interface. Similarly, the second configuration shows how PLC modules can be connected thanks to spring or battery connectors by siding modules left and right on the DIN rail, or by directly placing the PLC modules next to one another from the front position. As we have seen, any expansion modules, like communication modules, can be connected to the system via two types of the connectors. On top of this, it is crucial to offer reliable interconnect solutions to support the central role of the communication modules in the PLC architectures, which is the transfer of data. For this, we have two different categories. We still have the connection of the modules, but also the communication interconnect solutions, like USB and RJ45. For this purpose, modular jack, RJ45, and USB-C Type-C interfaces are the most popular connectors. On this slide, you can find our popular product series in these categories. Main features are space-saving design, along with high-performance specs for optimal user experience. The final stage of our teardown concerns the backbone of the PLC structure, which is the rack connectivity. Among our rack connectors, you can find two main series. First, you have millipacks 2mm, whose tulip contact can withstand vibration environment and be adjusted in backplane, coplanar, or mezzanine configuration. Secondly, you have Metrol, with its shielded structure for improved signal performances. Its stackable design allows blind mating compatibility, so customer can design high-density configuration. As solution provider, we plan to expanding and improving our range of connectors to further support our PLC customers with innovative NPIs. Here is a summary of the recent product launches over 2025 and the upcoming 2026 NPI, along with a small introduction with regards to their purposes, problem-solving features, and benefits. Among these NPIs, we can highlight Metrol Cable Connector, which is a cable-to-board solution complying with IEC 61076-4-104 and optional shielding. Its stackability and latching feature will ensure positive locking. Densiment 125, which is designed to offer reliable and secure retention in small pitch wire-to-board configuration, thanks to its U-shaped groove. Our next generation of board-to-board connectors will feature dual beam contact and upgraded design to prevent misalignment over plus or minus 0.1 mm and support PCIe Gen 4. So 0.8 pitch will remain, thus making this solution a very compact connection. Finally, the power connected DIN will be offered under power and hybrid versions, able to reach up to 10 amps with 48 contacts. This new solution can be used in board mount for rack configuration or crimp-to-wire for wire applications. At this stage of the webinar, I will briefly relate to the main success factors that contributed to past year successful projects with a focus on PLC. For the first case, the key element that comes to our attention is the explicit need from customer to design in the most reliable component. Our prior experiences with other industries convinced the customer to test and evaluate our SFV series. Thanks to the long-term performances, the customer decided to select this solution across the whole platform. The second case relates a space constraint expressed by customer on top of challenging temperature range with high variations. To satisfy their needs, we decided to promote Minitec 2mm with reinforced contacts, ensuring longevity despite high number of mating cycles. The housing material was also upgraded to face large temperature gaps without any compromise on quality. The last case highlights the engineering support that we can deliver to support our customers. In this case, Amphenol Basics had to carry out a share patent analysis within 4 weeks to meet customers' deadline. Thanks to our strong partnership with Signal Integrity Laboratories, our engineering team was able to prove that our concept could meet the high-speed requirements from the customer, up to 16 gigabytes per second. And for this, we had to release and design a new shield. For the last slide, I invite you to go through our product line overview. Starting with board-to-board, which is usually used in small board-to-board distance with high number of contact points, up to 120. This range offers technical features such as locking, self-alignment, high-speed communication, up to 25 gigabytes for microspeed, and we are also able to support flex cable solutions from wide range starting from 0.4 to 2mm pitch. We can also offer flex fold cable and FPC cable solutions in 0.5 pitch. Here is the product overview where you can find the main product series already available. And same for the 1mm pitch variant. Please feel free to access our web pages and product presentations for more details. The I/O portfolio is covering RJ, USB Type, USB cables. Do not hesitate to reach out to your sales contact person if you need any cable assemblies. The DIN backplane portfolio is our main solution provider for the rack connectors. Our factory in Cochin, India, is striving to achieve higher standards and promote these solutions in many applications. The core wired to-board portfolio is primarily designed for industrial, consumer, and IT datacom applications, and includes proven brand names like Minitec, Buckstick, and Quickly. It is split by pitch, so first question to consider when browsing our offer is to confirm the initial pitch, and you can find any declination, whether you have specific plating requirements or number of positions. The final slide of this webinar shows the different tools that you can access freely on our website. These tools include 2D drawings, 3D models, datasheets, application sheets, specs sheets, presentation, overview, live chat. If required, you can contact our tech support team, available 6 days a week, to answer your question and find the information you need. On top of this, our product management team is also there to guide you and answer your questions. Here is the end of this webinar. I hope that you have found useful information and learned about Amphenol FCI basic solutions. Thank you.
Great, thank you, Francois.
Welcome.
And just to kick off our live Q&A, I do already have some questions for you. So my first one being, what are the main factors to consider when selecting an interconnect solution for a PLC application?
To me, let's say the first factor would be reliability over time. We know that these PLCs need to operate in demanding environments with, of course, high stakes. If the production lines are stopped, you can imagine there would be some consequences. So for this reason, the connectors that we have to select and offer need to be reliable and industry proven. The second factor could be electrical and signal performances, because they are key to a successful interconnect solution. And we can see that the specs that the PLCs need to reach are always increasing. So the connectors must basically follow the same trend to match the ever-growing expectations with regard to signal integrity and currents, for instance. And the last factor to consider is definitely space constraints, because more and more demand, let's say requests from the customers are gravitating towards reduced dimensions.
Thank you, Francois. And my next question is, what connector challenges do customers most often face when scaling modular PLC systems?
So, in my opinion, finding the balance between standardized and customized solutions is the biggest challenge. For sure, modularity is where we need, as a, let's say, solution provider, we need to provide, let's say, the biggest added value because, of course, each customer faces their own constraints that we need to consider, and that means all connectors should be able to be adjusted accordingly. One example that comes to my mind is the adjustment of a pin length or resin material or a new plating configuration. But the downside of this approach is, of course, can be reflected in the tooling expenses or the lead time for deployment for a new solution. So, which is not the case for standardized solutions.
Thank you. And I do have one last question. Could you just recap the differences between microspeed and universal contact system?
So these two are quite similar in terms of purposes. They serve the idea of connecting the modules with one another, but the main differences lie in the EMI shielding and high-speed performances for the microspeed series. And on top of this, microspeed connectors favor sliding connection, whereas the universal contact system is more in front.
Thank you. That is all that we have for you today. Thank you, Francois, and thank you to everyone for joining us today.